Okay, welcome to the last video for Unit 9 over gas stoichiometry. Okay, so how is gas stoichiometry different from what we've done before? You guys have done a lot of stoichiometry in the past, and when you did that stoichiometry, you usually started with either grams or moles, and you found either grams or moles. But with gases, we do not use grams to measure gases because they have a very low density. We use liters to measure their volume. And so one thing that's going to be different with gas stoichiometry is you're either going to start with grams or liters, and you can find grams or liters. So that's the new thing, is that liters can be found when the reaction involves gases. And so because we're going to be looking for liters, or starting with liters instead of grams, we're going to be using a different conversion factor that is on your reference sheet. In 1 mole of gas, because of Avogadro's, his research, he found that no matter what type of gas it is, 1 mole of a gas contains 22.4 liters at standard temperature and pressure. So that's key. If it says that the reaction occurs at standard temperature and pressure, and if you remember that is 1 atmosphere and 0 degrees Celsius, if it occurs at standard temperature and pressure, then you can use that conversion factor to convert between moles and liters. So let's work out an example. So the example that we're going to work out reads, how many grams of carbon are needed to produce 17.5 liters of carbon monoxide in the following reaction at STP. So it says that it occurs at STP, so that means we're able to use that conversion factor I just spoke about. And so the first thing you need to do is figure out what they gave you and what it is that they want. They gave us 17.5 liters of carbon monoxide, so that would be just the CO right here, this product. And they want us to find grams of carbon. So we are looking for grams of capital C. So we are going to go from liters to grams. What you guys are used to doing is you're used to starting out with grams of A and then converting that to moles of A. And then you can use the ratio to convert to moles of B and then find grams of B. That's what you're used to doing. And whenever you convert from grams of A to moles or vice versa, you got to use the molar mass. So anytime you convert between grams and moles, if y'all haven't noticed, we've been using the molar mass because that is the conversion factor for that. And then anytime you go from moles of A to moles of B, you had to use the ratio. And remember, the ratio are the coefficients in the balanced chemical equation. So you need a balanced chemical equation to do these stoichiometry problems as always. And if you look at the equation, it is already balanced. Now it's going to be a little bit different. Instead of starting out with grams of A, you notice that they gave us liters. So we are actually going to be starting out with liters of A, and then we're going to convert to moles of A. And the way that we're going to do that is we are going to use that conversion factor of 22.4 liters per mole. And then after moles of A, then we can convert to moles of B using the familiar conversion factor of using the ratio, and then we can convert to our answer, grams of B. Now, just like before, when you go from moles to grams, you're going to use the molar mass. So these are the steps that we are going to follow in order to solve this problem. So I would go ahead and copy that down, what I have written in purple, and then write the chart underneath that. Okay, so we are starting out with liters of A, and they gave us in the problem 17.5 liters of carbon monoxide. And so the first place we're going to go is we're going to go from liters of A to moles of A. So moles of carbon monoxide will be on the top, and then liters of carbon monoxide will be the unit here on the bottom. And so if you look at the conversion factor, says that there are 22.4 liters in 1 mole of a gas at STP. So that's where I got the 1, and that's where I got the 22.4. After we have moles of A, we're going to find moles of B. we're looking for carbon, so that is our B substance. And then moles of carbon monoxide, that unit will come down here on the bottom. Remember, when we do moles to moles, we need to use the mole ratio. There is a 3 in front of the carbon in the balanced equation, and there's a 2 in front of the carbon monoxide in the balanced equation. So remember, the ratio are just the coefficients. Pull that straight from the problem. Okay, and then the last step, we've got moles of B, so our very last one's going to be going to grams of B. Moles of carbon will come down here on the bottom. And so when we go from moles to grams, we need to use the molar mass. So I'm going to look on the periodic table and see how much carbon weighs. It weighs about 12 grams, and that is in 1 mole. So now you're just going to do what you've always done, which is multiply across the top, and then multiply across the bottom, and then top divided by bottom. So in your calculator, all the numbers across the top multiply, divided by all the numbers on the bottom multiplied. And so when you plug that in, you'll get 25.82, and this is grams of carbon. If you go back up to your chart, you'll see that liters of carbon monoxide got canceled out, moles of carbon monoxide got canceled out, and moles of carbon. You're left with grams of carbon as your unit. Okay, so be prepared to work out a couple of different examples of those tomorrow in class.